Okay, so today what we're going to do is we're going to continue on this proof writing stuff in 5.3. And this is the directions we got. So it says in the table, record in symbolic notation what Tahani may have written to keep track of Tia's statements. In the example given, note how Tahani is introducing symbols for lines, points in the diagram, so she can reference them again without using a lot of words. So the whole point of like the shorthand that I'm about to teach you is so you don't have to write all this stuff here. Like all of these words are going to be replaced by short little things. So let's see. Because we want to do this, I also want to grab the picture and do what they're doing on the side. So let me go grab the picture. So, oops, not that. My bad. All right. So I want to grab this picture, copy the picture, and put it over here so we can draw over it. Okay. So it says draw AB. Now everybody look at what they put. They put a little hat on AB. Does everybody see my little hat? That means segment. So somehow write somewhere and say that means segment. That's how we say it. Segment AB. Okay, that little line means segment. Okay, so draw AB, locate its midpoint M, and draw a perpendicular line through it. So here's AB. They located the midpoint M, so we need to label this M here. Now notice capital M is a point versus lowercase m, which means something else, which, I mean, if you want to remember, it means slope in math, right? And then it says draw a line perpendicular. It's perpendicular, meaning it meets it at a right angle through the midpoint, and they call it L, lowercase l. L is named the line. It's the whole line. So I could either call this line L, or I can call this line CM now that I have a point here. So it says we need to start with a segment and it's perpendicular already drawn. So done. Pick a point C on line L, which they did. Then it says we need to show that any point on the perpendicular bisector is equidistant from two endpoints. So I can pick any arbitrary point on that perpendicular bisector. She could have chose that, not that, that. Okay. And here's what we're proving. If we want to prove that this is equidistant, do you guys remember what we talked about? Equidistant. What words do you hear when you hear equidistant? What words do you hear when you hear the words equidistant? We talked about this last time. Yes, equal and distance. So they're basically saying this segment here is going to be congruent to this segment here. So I'm going to mark that I want to prove those congruent. So I'm going to prove that's congruent to that. How would I say that is congruent to that? What would I write here? What would I write here? So it says we need to show that this point is the same distance from the two endpoints. What would I write here? Technically, you're not going to be able to type it, right? Well, actually, you could, but not with the symbols. Yes, we're going to prove that AC is congruent to BC. Now, I need to put hats on these people. I need to put a hat on these people. Now, some of you got it wrong, so just fix it. Make sure that it's right. AC is congruent to BC. They have hats on it. What did this little hat mean again? What did this little hat mean? What did this little hat mean? Put it to the public, not just to me, please. No, this means congruent here. That symbol is congruent. Do you guys know that? So this is congruent. This symbol means congruent. Yes, very good. So we want to prove that segment AC is congruent to segment BC, we want to prove that segment AC is congruent to segment BC. Okay. So then this is what Tia's statement is. If we knew that the triangles were congruent, we could say that the point on the perpendicular bisector is the same distance from each endpoint. So what do we know about the two triangles that would let us say that they are congruent? So we want to prove that these two triangles are congruent. Okay. We want to prove that these two triangles are congruent. So I'm going to write triangle ACM is congruent to, now letters matter. Okay. When I write A, then C, then M, I have to write this triangle over here, in the same corresponding order. Okay. This is called a congruent statement. A congruent statement tells you a lot of information without listing all that information out. Okay, perfect. Thank you. Okay, so how would I talk about this? Choose carefully. A, then C, then an M. Choose carefully. I need a statement in here. I would love to wait for everybody to give me this statement. That's how legit and important this is. So right now, I need you to tell me triangle ACM is congruent to what? Triangle A, then C, then M is congruent to what? Yeah, good job. Okay, it's got to be in the same order. I've got 1, 2, 3, 4 out of 5 people right. This is how you know you're right, because A would match with the first letter over here. C would match with the second letter over here, and M would match with the third letter. Very good. 5 of you got this right. So I'm going to give you people points. Let's see, 1, and then you get, and the rest of you get this in here because I'm waiting on you. Okay, go ahead and write that. You have to put a little triangle symbol and then that. Okay, so this is called a congruent statement. Super important. It tells you all kinds of things. Let's pretend that we've already proved that these two triangles are congruent, okay? It actually tells you angle A is congruent to angle B. Angle C is congruent to angle C. Angle M is congruent to angle M. And then length AC, side AC, is congruent to side BC. Who is CM, segment CM, congruent to? Who is segment CM congruent to, according to this? Now notice, I'm not even pointing here. I'm only talking about these letters. So one more time. Who is segment CM congruent to? Yeah, it's actually congruent to itself. CM is congruent to CM because that's what it says here. CM is congruent to CM. CM is congruent to CM. Yeah, segment CM. This segment right here. And that's like an obvious statement, Ms. Johnson. Of course, CM is congruent to CM. Of course, I am me and me is me, right? No problem. So CM is congruent to CM. So notice AM, segment AM is congruent to segment BM. Got it? Okay. So the next thing that we're going to say is we know that both triangles contain a right angle. We know that both triangles contain a right angle. Okay. So then we would say that these two are right angles. Do you guys know how to label angles? Do you remember that from like 4th, 5th, and 6th grade? Do you remember how to label an angle? It's okay to say, no, I don't remember. Okay, so when I'm labeling this angle here, this angle right here, there's a bunch of different ways to do it. One of the ways to do it is by calling it by an A. So if I say angle A, does everybody see angle A? Good. Are we all confused on angle A? No, I don't. So the reason why we're not is because how many angles are coming out of point A? How many angles are coming out of point A? Very good. One. Only one. Now look at C. How many angles are coming out of angle C? Count thoroughly. Someone said one. Someone said two. Very good. It's three. Someone said three. Is your chat not working, bud? Oh, that's why. Yeah, there's three. So let's talk about the three. Ready? One, two, three. So do you see how I can't say angle C? Why can't I say angle C? Do you remember we talked about this the last time? Right? We can't say it because there's so many angles. So I'm going to label the one on the left-hand side angle ACM. I'm going to label the one on the right-hand side by BCM. Okay. So now I need to label that both of these are right angles. Can you label in here, just write angle blah, blah, blah is a right angle. So I'm going to write this for you. I'm going to say angle blah, blah, blah is a right angle. So I need two angles. I'm not going to write them because I want you to practice, because some of you are going to fail the test because you don't know how to write your angles properly. Okay, once you have those two angles, put it in the chat so I can check you. Okay, what'd you guys put? So I want these angles all the way down here. So some of you put ACM. So follow my cursor, right? ACM. Those are the right letters, but it's in the wrong order. So I want this angle down here. So when I say ACM, C is my pivot point. C is my pivot point. It's the vertex of that angle. So that's not the angle I want. I want the M down here. Yeah, very good. So someone said CMA. So that's one angle. CMA is a right angle. What's the other one? Very good. CMB. Very good. CMA and CMB. Very good. So are you guys feeling a little bit more comfortable with our notation here? Your notation, I'm just going to tell you, is going to be the part that either helps you pass the next test and get an A, or it's going to be the part that doesn't make sense. Okay. So CMA and CMB are both right angles. Good. This one says, and we know that the perpendicular bisector cuts segment AB into two congruent segments. Oh. Someone said, hey, Ms. Johnson, how come we can't write it AMC? How come we can't write it AMC? We actually can. So I'll write that over here. Just as a little note. Angle AMC is the same as angle CMA. Not a dumb question at all. These two are the two different names for the same angle. So you guys all call me Mrs. Johnson. My children call me Mom. There's other people who call me by my first name. I'm still the same person. This is still the same angle, just different names for the same person, right? Okay. Very good question. C is on the straight line. Oh, no. You can actually, both of these are, I could have written AMC for this one. It's just like, how it's, my name's Bond, James Bond. You know how sometimes people write your last name first and your first name last? It's just like that. Okay, this one says, and we know that the perpendicular bisector cuts segment AB into two congruent segments. How would I write that here? How would I write this in shorthand here? What would I do? Who's congruent here according to what this says? Who is congruent according to what that says? Yeah, just which part it says into two congruent segments. Very good. Someone said, hey, Ms. Johnson, is it AM congruent to BM? Right? AM is congruent to BM. Yeah, AC is congruent to BC. That's what we're trying to prove. Okay. So what did I forget? I forgot it on purpose, but what did I forget? What did I forget in this statement here? Yeah, very good. They're hats, right? Very good. They're hats. I'm going to have to show you how to do this on Desmos. I'm going to have to show you how to do this on Desmos. The easiest way to do it is by copying and pasting. I'll show you later. Okay. Then it says, obviously, the segment from C to the midpoint, so CM, is congruent. Obviously, the segment from C to the midpoint of the segment AB is a side of both triangles. So who are they talking about? From C to the midpoint. Who are they talking about here? From C to the midpoint. Who are they talking about? Very good. CM. They're talking about CM. This is going to be a weird statement. CM is congruent to CM. CM is congruent to CM. Ms. Johnson, do we have to say that? Yes. Yes, we do. Okay. Do you guys remember the triangle congruence? Side, 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 side angle, side. I think you learned it last year. Good. So this one is called side angle side because we have, we have in this order a side, the angle, and a side, right? Side, angle, side. So we would do this. Does everybody see my side is congruent to side? My angle is congruent to the angle, and the side is congruent to itself. So this is called SAS, right? So the triangles are congruent. What would I write here? The triangles are congruent. Which triangles are congruent? What would I write here? Can you write this out for me? Can you write this out for me? Again, this seems like we're practicing weird stuff, how to write stuff, but I'm going to tell you, this is almost like, how do I put this? This is almost like learning how to write your numbers, right? In a little bit, I'm going to give you a test. But if you don't even know how to write your numbers, how are you going to do on that test? So if you don't know how to write our symbols, right? Just make sure that when you write your triangles, that order stuff matters, right? And it doesn't matter the order as long as the two orders match, right? It's called respectively in regular English. It's called corresponding in math. It's like this, right? Like if I said, I teach, and I'm only going to talk about 3. I teach 3 periods today, right? I teach MRWC, which is a senior class, integrated 3 and integrated 2. Those periods are respectively periods 1, 3, and 5. So because I mentioned them in a specific order, you can assume that the first thing I mentioned was the matches with the first thing that I mentioned, right? Period 1, MRWC, they match. Same with the other ones. So can you write out my triangle congruence statement here? Write the triangle congruence. Yeah. And then it's kind of interesting, and I wish I can show you all the different ways that people are doing it. Is some people said AMC to BMC. Do those match AMC to BMC? Yeah. And then someone else said ACM to BCM. Sure. Could someone say CMB, CMB to BCM? Could we say CMB to BCM? Yeah, you can't. You can't say C, then M, then B, because C doesn't match with B. So CMB would match with CMA would match with CMB. So whichever way you did it, I'm just going to write the last one that I said just because it's on my brain. I would put a little, I would put a little triangle. Why are you doing this? My pen is going cuckoo. Did I say CMA to CMB? Perfect. Lastly, since the triangles are congruent, segments AC and BC are congruent. Can you write that here? Segment AC is congruent to BC. Can you write that here? Don't forget the you know what I'm talking about. Don't forget the you know what I'm talking about. Okay. What did you write here? Yeah. You could say CA is congruent to BC. Now, when you're writing congruent statements for segments, order doesn't matter, right? Order does not matter. So those two are congruent. So then that proves that any point on the line is going to be equidistant. So we're done. This is called a proof. Okay. We are going to get into more of a proof when we look at this stuff down here. So it says Tawny thinks Tia is brilliant, but she would like the ideas to flow easily from start to finish rearrange Tahani's symbolic notes in a way that someone else can follow the argument and see the connection between ideas. So this is where I want you guys to do this one here. And I think we are, where am I? Here. So you're going to rearrange these so that it flows better. So what do you mean by flow better, Miss Johnson? So if this was an essay, like, how would you make this flow better so that, like, from beginning to end, it makes sense? Now, there's certain things that are kind of like brushing your teeth or making your bed. It doesn't matter who goes first, but there are definitely things like socks, then shoes, that you'd have to do one before you get the other. Does that make sense? So when I'm looking at this, right, you're going to have two columns and you're going to basically have all of the statements. So whenever I tell you, I'll just do this. The very first thing that you should do is put all statements on one side and then put all reasons on the other. So I'm going to do that really quick. I'm going to put this over here and this over here. And then I'm going to put this over here. That's a reason. This is that. This goes over here. This goes over here. So the very first thing I'm going to do is I'm just going to arrange these like this. Okay. I will tell you right now, the first reason that you will always do is given. Okay. You will always start with a given. So based on this, I will show you over here. What did they tell you? What did they give to you in the very first thing? What did they tell you in the very beginning of this proof? So they're looking at their homework, the points on the perpendicular bisector. Yeah. So here they're given that that line L is a perpendicular bisector of AB. So when I'm looking over here, what they gave me is that L is perpendicular to AB at point M. So I'm going to have two things that are going at the same time like this. Does that make sense? Okay. Now that we know that is true, then I'm going to look at my little notes down here. What made the most sense next? So it says that we have to prove AC is congruent to BC and that any point is on the line. So that means that's going to be our last thing. So the last thing is going to be, let's see, looking for, is it AC's? No, CM, no, AM. It's going to be this one, right? This is the last thing that we're going to prove. So now from here, I'm just going to rearrange all of this to get that. Does that make sense? I'm going to rearrange them so that's it. So once I know that it's perpendicular and it's a bisector for midpoint M, what's another thing that makes sense? Because it's, so the way I want you to think about proofs always goes like this. Now I know this, then what? What logically is the next thing that would follow? And I'm just going to tell you, there's many things. There's not one. You could do this part. You could do this part. There's a bunch of different ones that you could do. Oh, I'm wrong. This is not it. It's this one. AC is BC. This is our last step. So looking at all of these statements here, let's do this. So that makes more sense. Yeah, that's good. So what would come next? Yes, very good. When we know that something bisects, let's look at the picture. That's a really good point. When we know that this bisects, what do we know? Very good. Because we know that this thing bisects, what else do we know? So because one of your classmates said the bisector, that means the second thing we're going to use is the bisector. What do we know if I say, hey, look at this picture. I'm saying this bisects this. What do we know? Which one do we know that AC is congruent to BC? Nah. Do we know the triangles are congruent? No, very good. Good job. Do we know the angles are right angles because it's a bisector? What do you think? Yes or no? It's okay to say yes. It's okay to be wrong. Who cares? Because it's a bisector, do we know that they're right angles? Everyone say yes or no. No. Because it's a bisector, no. Because it's perpendicular, then we know it's right. Okay, so let's put that together. Let's say that. Because it's perpendicular, do you see how this goes? Because this is, because we know that it's perpendicular, it forms right angles. Does that make sense? Very good. So let's move on. Because it's a bisector, do we know that AM is congruent to BM? Because this is a bisector, do we know that AM is congruent to BM? What do we think? Yeah, that's right. We do know. So I need you somewhere in your head to write this down. Bisector, two congruent parts. So whenever I use definition of bisector on this side, it's going to say something's congruent to something. So can you remember what bisect means? Bi means two. Sect means cut or sections, right? So I'm saying, here's a brownie. I need you to bisect it. It doesn't mean what my brother did when we were younger. He'd take the brownie and he'd cut it here and be like, this is your piece. This is my piece. And he'd smile like this, right? No, that's not the same. Okay. That's not bisecting it. That's cutting it, but not bisecting it. Did you guys do that to your little siblings? Yeah, you did. Yeah. Just kidding. Okay, so again, what does bisect means? It means two congruent parts. Okay. So when I'm bisecting, I don't know, maybe I should use this word, right? I need you to bisect your homework and do some of it tonight and do some of it tomorrow. Bisect means you're going to do exactly half tonight and the other half is tomorrow. Does that make sense? Or tonight when you're at dinner and you want to bisect a tortilla, like to split with your brother or something like that, right? Don't give them this tiny little piece and be like, look, I cut it. You have a piece and I have a piece. Be even Steven with it. Does that make sense? So is everybody comfortable with what we have so far? Okay, so let's look at our choices. What comes next? So I'm always going to ask you, so what? So, okay, according to this, we have, because it's perpendicular, we use that idea. Because it's a bisector, we use that idea. Okay, now that I know that this is congruent to this, and these two angles are right, what would happen next? Would you prove that oh no, sorry, this goes down here because this is last. I shouldn't have moved that one. Do we know that CM is congruent to CM? Do we know that angle? Can you guys look at this angle CMA is congruent to CMB? Do we know that CMA is congruent to CMB right now, looking at the information that we have? Yes? No? Let's see what we have so far. So we have AM is congruent. Maybe I should erase this and like start all over again. So let me erase all of my markings. Oops, just kidding. I didn't erase. Okay. So I erased it. And then it says AM is congruent to BM. Done. We have CMA and CMB are both right angles. Because they're both right angles, what does that also mean? What does it mean to be both right angles? What would come next? Yeah, someone's remembering that a whole line equals to 180. Very good. So let's look at our choices. Because we know that the angles are right angles, do we know that AC is congruent to BC? No. Because we know that these two are right angles, do we know that the triangles are congruent? What did we use to prove the triangles are congruent? Do you guys remember this? Oh, I can't scoot it over. Oh, there it goes. What did we use to prove triangles are congruent? Triangles, oh, by SAS. By SAS. No, we don't have SAS yet. We only have that, let's see. We have a side. Oh, we don't even have an angle yet. Okay, do we now know? Yeah, it's that one. Very good. So now that we know that they're right angles, do we now know that angle CMA is congruent to CMB? Do we now know these angles are congruent? If this is a right angle and this is a right angle, do we know that these angles are congruent? Everyone say yes. Very good. Okay. So why? Why do we know these angles are congruent? Why do we know these angles are congruent? Because the distance between endpoints are congruent? Because of SAS? Because of corresponding parts of congruent triangles are congruent? Because of reflexive property? Because of right angles? Which one of these would help you prove that these two angles are congruent? Yes, very good. Because we had just said they're right angles. Okay, here's a little tip. You'll never use definition of right angles. Wait, how do I put this? You can't say definition of right angles if we haven't mentioned that they're right angles. Here, definition of perpendicular was given at the given, right? L is a perpendicular bisector at M, right? So whenever you see definition of perpendicular, look above it and make sure. Oh yeah, it says it right there, perpendicular bisector. Oh yeah, they gave it to us, right? Okay, so what? So now that those angles are congruent, I can go like this. This is how Miss Johnson marks that these two angles are congruent. She marks them like this with little arc marks. So I have a side. I have an angle. Oh, I can't put this triangle one yet. I can't put the triangle one yet. Which one comes next? Which one would come next? So it's not the triangle one. Not yet. We can't use SAS yet. Because in order to use SAS, I need a side, an angle, and a side. And so far in my diagram, I have a side congruent to a side. I have an angle congruent to an angle, but I need that third side. Yes, very good. I'm going to put here that CM is congruent to itself. Why is that so? Why is CM congruent? Because corresponding parts of congruent triangles, distance, SAS. Why? Which one of these makes the most sense? Stay with me. For those of you who are like, oh my gosh, Miss Johnson, how do I do this? Stay with me. This is like one of those things like you practice how to ride a bike. The first time, it doesn't make sense to you. No, we can't use this one. I will tell you right now, we will use this one after we prove these triangles are congruent. After. This one says corresponding parts of congruent triangles. Do we have congruent triangles? No. So this one's going to be later down here after this one. Does that make sense? Okay, what comes next? So it's not that one. It can't be this one because this is actually the distances between endpoints of congruent line segments are equal. This is not this. This is not. Yeah, it's reflexive. Reflexive property reminds me of a mirror. Like when you look in the mirror, what do you see? Yourself, right? This is itself. Does everybody see that? He's looking into the mirror and he's like, oh my gosh, I'm so cute, right? Because he sees his reflection. Reflection. Good. So reflexive property is always going to be something is congruent to itself. Okay. Okay, so now if you look, I have side, I have angle, and I have side. I have side, angle, and side. So now can I use the side, angle, side, Miss Johnson? Yes. So if side, angle, side is on this side, what goes here? Yeah, right? What goes here? Yeah, very good. The triangles. So the thing that you're proving with SAS is triangles are congruent. SAS is used to prove triangles are congruent. Okay. This is like if I asked you guys, hey, can you bring me can you prove to me that you are really you, what would you show me that you are really you? What's something that you can show me that you are really you? What's a piece of evidence that shows that? Yourself. Yeah, you would use a birth certificate, a school ID, a California ID, something that shows that you are doing this. Okay, what comes next? What's next? Well, the only one that could be is one of these two, right? So I'll tell you that this one comes next. What did I tell you always comes after triangles are congruent? What always comes after triangles are congruent? Very good, corresponding parts. For short, some people say C, P, C, T, C. Corresponding parts of congruent triangles are congruent, meaning now that I've proved these triangles are congruent, I now can prove angle A is congruent to angle B. Side AC is congruent to CB. And then this one right here goes with this one right here. Okay. Now, I will tell you right now, can you move this one? Let's see. Which ones were the ones, Miss Johnson, that had to come before this? In order to use SAS, I needed to prove that a side, an angle, and a side are congruent. Do you see my SAS? Everybody see SAS? Does everybody see that? Yeah. So I can't put this one up here, Miss Johnson? No. Because if you put this one up here, that means before it, I would have to see an S, an A, and an S, and I don't see that. So this one has to come after this one. Well, what about this one, Miss Johnson? Can I move this one up? No, because how did you get this? I got this because corresponding parts of congruent triangles. Oh, congruent triangles is this. So no, I couldn't move this one up because I need these two together. Okay. This last one basically says that if they're congruent, then they have the same measure. If these two things are congruent, then they'll have the same measure. For example, like if I take like say I say that these two segments are congruent, and I know that the first segment's length is 9. What do you know about the second segment's length? Same, right? Okay, very good. Miss Johnson, which ones could we have switched around? I could have moved this one down here, but it had to come before side angle side. Okay. So those are the only ones. Like these ones right here, these three, actually these two, we could have switched. This one had to come after this one. Tell me why this one has to come after this one. Logically speaking, why would this one, this statement here, have to come after this one? What's its definition? What's the reason? Yeah, very good. Someone said because we have to know it's a right angle first. Perfect. Someone else says because you have to prove that it's a right angle. Exactly. You can't use the definition of right angles. Like imagine me putting this here in front or on top of this one. Definition of right angles. That doesn't say anything about right angles. That doesn't say anything about right angles. So how are you using a definition of right angles when right angles don't exist? Right? So imagine that this is a story, and it is, that you can't, like, think about any really good movie that you like, right? You can't introduce a character and just have them like start chatting with the main character unless you have some kind of background about this character, unless you're using that conversation to introduce the character. Does that make sense? Right? It's this, like, if you think about this as a story, then it's a little bit, it'll make more sense. All right. Would your justifications be true regardless of which point you chose? on the perpendicular bisector. So they're saying this, like, what if I chose this point down here, or this point right here, or this point right here? Do you see how your statements, let me go back to my statements on here. Do you see how my statements are true regardless if I chose a point C anywhere here? Do you see how that's true regardless? Does everybody see that? Yeah, kind of. So what if I chose it down here? Do you still have that AM is congruent to BM? Here, let's put a blue point down here. And like, okay. So let's say I chose this point right here, and I can slide this point all the way here. Everybody good? So look, let's see if it's still true. Is AM still congruent to BM? Yeah. Is CMA, angle CMA and angle CMB, are they still right angles? CMA and CMB, are they still right angles? Yeah. And then are those two angles congruent? Yeah. Is CM still congruent to itself? Yeah. Are the triangles still going to be congruent? Yeah. Therefore, these two are going to be congruent because of CPCTC. Yeah. So I could have chosen this point all the way out here that's still on the perpendicular bisector. Sure. Do you know what I see this as? I don't know if this is what you guys see as, but this is what I see. Like, I imagine this to be like, have you guys seen a crossbow or a bow? Do you guys all know what a bow is? Yeah. If I take a rubber band and put it across this way and pull this rubber band back, I know that this side of my rubber band and this side of my rubber band are equal, right? As long as I stay in the middle. Now, if I start veering off to the side here, can you imagine me putting a point like, I don't know, somewhere here? Like if I put a point somewhere here, do you see how these two lengths from this point, I'll just call this D, from D to B and from D to A are not the same anymore? Does everybody see that? Kind of. Because it's on the perpendicular bisector, that's why it works. Okay, very good. This one says, what challenges do you encounter understanding the translation of the verbal language into symbols? I'm just going to tell you, you'll get used to it. I know some of you are already used to it because you remember some of the stuff from last year, and some of you are just getting used to it, which makes sense. Why does your sequence of statements seem like a logical order? So go back here. We talked about taking these people and putting them out of place, right? So it's always going to be this before that. Like, can you imagine this morning when you got ready and you put your shoes on and then your socks, right? That's like, no, I wouldn't do that, Miss Johnson. Okay, then you shouldn't be putting SAS before you've proved S, A, and S, right? Can you imagine when you got ready this morning that you were deciding, should I put on, or should I make my bed, or should I brush my teeth first? Right? Most of us have a routine and we don't even think about that anymore, right? But that literally is a decision that maybe I choose something different than you and it would still work out the same way, right? So just think about why that actually makes sense. Last but not least, you can use Tia and Tahani's theorem about points on a perpendicular bisector of a segment to prove the base angles of an isosceles triangle are congruent. Okay, so wait, what? Okay, let's read this again. To prove that the base angles of an isosceles triangle, does everybody see the isosceles triangle in this picture? Does everybody see the isosceles triangle in this picture? Do you guys remember isosceles? How many sides are congruent in an isosceles triangle? Very good. 2, right? 2 of them. So I see side A. We already proved this, right? So this side here is congruent to this side here, right? Okay, this side is congruent to this side. So they're saying that the base angles are congruent. Everyone say base. Base. Where do you think the base angles are of your isosceles triangle ACB? Where are your base angles? Angle what? Name one of your base angles. Just guess I haven't told you this, but just guess. Yes, very good. A and B. So the reason why these are called base angles is because, like, first, this is called your base, right? The base is the non-congruent side in an isosceles triangle, right? So the base angles would be the angles attached to your base. Some people describe this as the bottom of the triangle, but I can draw an isosceles triangle like this. Right? I can draw it like this, and it's not on the bottom anymore. So just know that it's the sides, the angles that are attached to the non-congruent side. So can you actually prove that these two angles are congruent? Think about what we already have proved congruent. We already have proved that these two triangles are congruent. Do you know if angle A and angle B are congruent? Are angle A and angle B congruent? Yes, good. Good. Okay, I'm going to let you cheat a little bit. Why? It's one of these reasons. Why is angle A congruent to angle B? Why is angle A congruent to angle B? So you're thinking, not given. It's not a bisector. It's not perpendicular. It's not definition of right triangles. It's not a reflexive property because angle A and angle B are different. So not reflexive, right? Because they're different. The only thing that could be reflexive is if that and that match, right? It's actually this one right here. Corresponding parts of congruent triangles are congruent. So angle A and angle B are congruent, right? They correspond. Very good. And these, we already proved that these two triangles are congruent, right? So once I prove these are congruent, I can literally take all the parts of the triangles and say they're congruent. So very good. Those are congruent. It says, so this is one that I want you to practice on your own, and that's pretty much all we're going to do today. So I'm going to go over takeaways, and then we're just going to call it a day. I'm going to have you guys start looking at your exit ticket and homework, and then I'm going to make sure that you guys are ready. So writing the story of a diagram and the conclusions that can be drawn from it is central to geometric proofs. Like any other text, a proof is written by an author and has to make sense to a reader. So it must be thoughtfully constructed. Okay. So that is, writing a proof begins with a proof idea, right? Writing a proof becomes a proof idea, right? Hold on a second. So what does that mean? It's like, it's almost like that. Like, do you remember how you used to do outlines and like the thought little bubbles, the web of like ideas? It could start like that. I usually start with my given and I say, okay, now what do I know? Okay, now that I know that, now what do I know? Okay. Every proof starts by stating what we know. Remember, we said it starts by the given. So here, write given. Starts by stating the given. Okay. And a statement of what we are trying to prove, right? We were trying to prove in that last one, we were trying to prove that those angles are congruent. So the proof, up here. So the proof is built in successful logical steps. Like I like saying, and now what? Or because why? Those are the two questions I ask myself over and over again. No, you're good. You could just leave it. I will lock it. You're done. You're ready for me to lock it? Okay, perfect. Thank you. Perfect. See you later, hon. I appreciate it. Okay. So then, and then a proof ends with a conclusion based on what you like, kind of like based on the reason. Okay. So this is how a proof goes. We start with what was given. We end with what they told me to prove. And then these were all steps that made sense in order. Okay. Now, some of you are freaked out because you're like, oh my gosh, Miss Johnson, what if I get the order wrong? Just make sure that it makes sense, right? Pretend this is a story, right? This is a story that I'm telling. Oh, I'm going to go back. So, see, it started with a given. They told us what to prove. Then we built it by saying, okay, because we know this, now what? What else do we know? And you guys said, okay, we know this. And because we know this, now what do we know? Because we know this, now what do we know? Why do we know that? And some of them were definitions. Some of them were like postulates that you guys learned in the past. Okay, let me just continue really quick. Okay, so it says proofs can be written in different formats. So far, we've seen 2-column proofs. That's what we did today, right? And then a paragraph proof, which I'm okay with, but it's not my favorite. Today, we proved the perpendicular bisector theorem, okay? We proved that perpendicular bisector theorem. So this is something that I want us to write over here in our like little notebook of theorems and stuff. So I'm going to write it here. It's called the perpendicular bisector theorem. So whenever you see theorems, you'll see an if part and then the then part, right? So if you do your homework, then then you're going to learn how to practice this information, right? So this one says if a point is on the perpendicular bisector of a segment, what did we learn? Then it is equidistant from the endpoints of the segment. Okay, so now if I showed you the exact same picture of what you saw today, and I said prove that this is congruent to this, and I gave you that it was a perpendicular bisector, you don't have to go through this whole proof. Boom. You could just say, I know they're congruent because of the perpendicular bisector theorem, right? So let's continue. Sorry. Oh, that's not it. I'm lost. Okay. We also examined the details of a proof for the base angles of an isosceles triangle. So that once you prove that, then you have access to that theorem, which is basically, I think it's, so there's an isosceles triangle theorem. Did you call that? I don't know. But the base angles of an isosceles triangle are congruent. So now you don't even need to prove that anymore because boom, that's a theorem, right? So let me finish off our takeaways and I think we're done. Okay, so the perpendicular bisector of a segment is the line that passes through the midpoint of the segment that forms a right angle with the segment. So this is the definition. Make sure that you're comfortable with, the couple of theorems that we've started with. By the end of all of our geometry sections, we have quite a few. We have this one, this one, this one, this one. We'll have a whole list of things and you can organize it how you want. The best way to get this stuff in your head is by using it over and over again. So over here, when you're doing your exit ticket and your ready, set, go, make sure you're using this information, right? Like look at this. It says complete the following proof in either 2-column or this. It says given that ABC is an isosceles triangle and M is the midpoint, prove that angle A is congruent to angle B. So this is going to look very similar to the proof that we wrote together, except for now we have angle A and angle B, which is why I didn't finish it, because here it is. Your goal is to write a proof. Okay, and then over here in your ready, set, go, this is ready. In your set, you'll see if you know these things, how can we prove other things, right? So you say statements like, because I know this, I know this. Because I know this, I know this. So, and then here's a 2-column proof for you. So there's a lot of practice for you to get out of feeling uncomfortable when you're writing proofs. If you don't like writing proofs, just practice what you do know, okay?